Hey, we are talking about matrices, so let's take a look. The first thing you'll see on the video here is an example of a matrix. We've got 6 elements in this matrix. We call it, with a capital letter, capital A. And a matrix is just any rectangular arrangement of numbers, rows, and columns. So rows are left and right. So right now we've got rows, and columns are up and down. So think columns like in a building. Columns are up and down, holding the roof of a building or something. So columns up and down. So there are 2 rows and there are 3 columns. We have dimensions of a matrix. Dimensions are important because we will need those later when we start adding, subtracting, and multiplying. But we label those with rows and columns. So this dimensions of A is a 2 by 3, 2 rows, 3 columns. I like to think of making an L down the side. So if you'll see an L here, 2 by 3. 2 down, 3 over. And then, of course, those things in a matrix we call elements. There's a couple of things that we can do with matrices, the first of which is just add and subtract them. The one thing though, the matrices must have the same dimension. So this is a 3 by 2 on the bottom. This is a 3 by 2 going down 3 over 2. The next matrix again is the same. This matrix below is a 2 by 2, and this is a 2 by 1. And unfortunately, we won't be able to add these things. So we just say that this is undefined. You cannot actually subtract these 2 matrices. But the top one we can. And all you do is go element by element. So I'll start with the top left element, -2. Add that to a 1. And you get -1. And that just goes then in the corresponding element over on this matrix. Then you go to the next one and you say, all right, well, take 0 and -2, add those together, you get -2. And that slides around over here. And then finally, we take so on, just moving down, around, anywhere along the matrix. 7 plus 1, you get 8. And then 8 slides right in there. You would continue on the same pattern over here. You would have a -3. You would have a 12. And then finally an 11. And there is a matrix added together. We've got programs that can do this for us, different calculator operations, so we won't have to do this very often. The one way I will ask you to just show that you can is by looking at variables, and we'll get to that example in a second. The other thing that you can do pretty easily with a matrix is called scalar multiplication. And this simply is just taking something out front, like a 3, and distributing it to every element in the matrix. So this would turn into 0 times 3, which is just 0. And then 3 times 2, which is 6. And then 3 times -7, -21. And so you're just doing a scale. You're multiplying each element by 3. You're scaling it up by 3. 18. And then 12. And then closing off your matrix. So each matrix has a square bracket on both ends, just to organize it so we know where the matrix ends, starts and ends. All right, so I would ask you to do this on your own. See if you can kind of piece together both scalar and matrix addition. See if you can bring this answer to class tomorrow. Matrix multiplication is a lot more difficult and will require a little bit more care. First off, the columns in matrix A must match up with the rows in matrix B. So what I mean by that is if you have a 2 by 10 for matrix A, then matrix B has to be a 10 by something, anything, question mark, it doesn't matter. But these two numbers right here must match up, the 10 and the 10. We'll see what I mean by that in a further example. So let's take a look at this. How do we multiply a 2 by 2 times a 2 by 2? All right, well, these inside numbers do match up, 2 and 2, so you are going to be able to multiply them together. How do we do it? Well, we take the entire row here and we multiply it by the entire column over here. So you take A times E and you add it to B times G. And that will go in as your first element in your multiplied matrix. And you can see that this is row 1, column 1. So this gives us row 1 times column 1 gives us element row 1, column 1. And you can move this over here. So now we're multiplying row 1, column 2. You're multiplying A times F and B times H. How do we get down to the second row? Well, you need to multiply the second row, and I'll go back to the first column. C times E plus D times G. And then slide it over one more time. It's C times F plus D times H. And that's how you multiply a 2 by 2. The general idea is that you're going to multiply entire rows by entire columns. And so that's why these two numbers have to match up. Right? These two numbers have to match up. Otherwise, if it didn't, you wouldn't have elements to multiply. So let's try it with this example. So we're going to multiply the first row times the first column. So it's 1 times 3 plus negative 2 times 7. That's going to be your first element in our matrix. Then I can move to the next column. It'll be 1 times negative 6. And then negative 2 times negative 1. And then we'll move down. We'll move to row 2, and I'll go back to column 1 over here. It's 5 times 3 and negative 4 times 7. And then finally, we'll go to the last column here. It's 5 times negative 6 plus negative 4 times negative 1. And now you just need to simplify. So quick addition, multiplication here. We've got 3 plus a negative 14 is negative 11. We got a negative 6 and a positive 2, so that's a negative 4. 15 and negative 28 is negative 13. And then negative 30 plus 4, negative 30 plus 4, negative 26. So these all turned out to be negative, but of course that's not always going to happen. But you can see multiplication. Now we'll explore in class why it is useful for us to have multiplication like this. Yeah, it would be easier just to multiply 1 times 3 and then negative 2 times negative 6, but not as useful for the power of what we use matrices for. I'd like you to try and multiply this. Remember, you're going to be taking the entire row, multiplying it by the entire column.